Hi everybody, welcome to Tech Tip Friday. I'm Kurt Staley, that plastics guy, and I'm bringing you a tech tip that you could take to the shop floor with you today. And today's tech tip comes from a conversation I had with a customer this morning concerning a grade of nylon that I had provided to them. They were telling me that they were having some issues molding a certain part despite playing with the temperature, raising the temperature to try and make the product flow a little bit better, and playing with injection pressure and injection speed. And they just could not get the part to either mold properly, fill the tool, or if they could fill the tool, demolding it was becoming a real problem. And yet they told me on another job that they run, that same product ran just fine. So what do we have going on? First thing, they asked me to verify if that particular grade of nylon was lubricated. The product nomenclature denoted it was lubricated, but I did check with the compounder that I purchased the product from and confirmed that it was in fact lubricated, because this is what you have to do when you're trying to root cause a customer issue. You do check everything. And I was glad that it was lubricated because I had asked for it, was specified, quoted accordingly, and that part of it was good. Now the next thing that came to mind was, well, okay, what are we doing with melt flow? But in nylon, we don't talk about melt flow, we talk about viscosity. So in the majority of resins that you're going to come across, the basic commodities, polypro, polyethylene, the styrenic family, even some of the engineered products like polycarbonate, we measure the material's ability to flow based on a melt flow process. And I've done a long format podcast, I've done Tech Tip Fridays talking about how melt flow is measured with a calibrated instrument, and putting pellets of material into a heated orifice. It drips through the instrument, it's collected, that amount is weighed, and you calculate how much material flows over a set period of test time. And it's done to either an ASTM standard or an ISO equivalent at a certain temperature, and that's very key, and you get a melt flow number. And the higher the number, the more material will flow, and it transitions from solid to going through the bicat softening point to finally its molten state. I can't call it liquid because it's not technically liquid, but from solid to flowing state. Higher the melt flow, the easier it flows. So what's up with viscosity? Well, viscosity is a term that we use to talk about how nylon flows, but it's not the same way. It's exactly the opposite to melt flow. And to give you an idea of what this is about, I Googled viscosity so I could give you a good definition. And if you type viscosity into to the Google search engine, you'll get exactly the same thing. But I'm going to read it for you. Viscosity is a measure of a fluid's resistance to flow. It describes how easily a fluid deforms or moves when subjected to a force, in our case, hydraulic pressure from the injection screw. Fluids with a high viscosity, like honey, resist flow more than those with a low viscosity, like water. So based on this, you can see conceptually, it's an inverse relationship to melt flow. So a high melt flow would sort of imply a low viscosity, although we're really measuring two different aspects of a given material or given substance. And then of course, if you have a low viscosity or low melt flow, you would have a high relative viscosity. So low melt flow would require more oomph to push it in the injection machine or any plasticizing part of processing equipment. So a low melt flow would be a high viscosity. So for my customer, we're going to phase out the relatively higher viscosity material, which would act like it's a lower melt flow, and we're going to replace that with a lower viscosity, less resistance to being pushed, which would act like a higher melt flow material. So problem solved, that's how we'll deal with that. But it's something that comes up periodically, and I thought it would be worthwhile to do a little video on this, especially when it was a conversation just this morning at the time of recording. So I hope that gives you some insight. That is a great tech tip that you could take to the shop floor with you today. It'll help you to understand processing, and it's also a characteristic that can be applied to other things, hydraulic fluid, motor oil, these types of things. They will also be described in different viscosities, and if that's the kind of thing you're involved with on the shop floor, it's a really good idea to have an understanding of one of these basic terminologies that can describe some pretty critical things for your machine. So there you have it, viscosity versus melt flow in nylon, and you can take that to the shop floor with you today. Have an awesome Friday, a great weekend, and we will talk to you and bring you more good stuff next Friday. Thanks so much. Take care. Bye-bye.